Okay, I want to show you something else with arithmetic and geometric series that we talked about, and it's an interesting problem. First, I'll just do a really quick review for you. When you have an arithmetic series, then you're talking about a common difference. We often use D, and you can use the formula Tn is T1 plus, because you add the next difference more, n minus 1, D. And we're talking about geometric, then you're talking about a common ratio, and we use this formula for the nth term, T1 times the ratio that's common raised to the n minus 1 power. Okay, so the problem I want to look at is a really interesting problem, and I'll read it to you real quick. Let me write it first. Okay, so George has taken this job with a starting salary of $20,000, and the question asks you to find the salary during the 4th year on the job if he receives annual raises of, in the first case, A, he receives an annual raise of $1,100, and the second case, he receives an annual raise of 5%, okay, increase. So, let's take a look at how we're going to do this and how it applies. Okay, in the first part of this problem, they asked you for $1,100 raise annually. So that's going to be the common difference between every year's salary. So this D is equal to $1,100. And every year, that's just how much you increase it by. Okay, and we also know his starting salary will be T1. They gave us $20,000. Now, because we have this common difference, we just add $1,100 every year. This is arithmetic, okay? So we're going to use Tn is equal to T1 plus the n minus 1 D, and we'll find, as they asked us to do, T4. So T4 is T1, 20,000, plus, for n, we're going to use 4 minus 1, common difference, 1,100. So when you work that out, you get 23,300 as his salary in the 4th year. Okay, that's pretty straightforward. We like that one. The second part of the question will ask you to calculate if there's a 5% increase every year. So what do we mean by that? Well, if you start, again, T1 is 20,000, right? Then I'm going to add an amount that's 5% of this original. So I would take 20,000 times 0.05, okay? And I would get $1,000 is my raise this first year. So the first thing you're going to say is, wow, that's not as much as the raise before when it was $1,100, so it's probably better to do the other one. But be careful. This is just the first raise. Now, this 1,000 is not the second term in the sequence, okay? It's just the increase this particular time. So you could, T2 is the 20,000 plus the 1,000. And that's how we normally go about calculating increases like this, and you get 21,000. But this increasing by 5% is a geometric sequence. I need to find that common ratio, okay, to go from one year to a next. Well, here I can see that T2 was equal to the original 20,000 plus the 0.05 times 20,000. So I just need a formula that sort of sums this up for every time I'm going to do it. Let me factor out the 20,000, and I have 1 plus 0.05, or 1.05. So what did I do? I didn't add a certain amount, I'm multiplying by 1.05. And this is what's going to be constant ratio right here, okay? R is equal to 1.05 is that constant ratio. Okay, so now I figured out what R is, I know what T1 is, I can use my formula, Tn is equal to T1 times R to the n minus 1. So I can calculate T4 is equal to 20,000 times R which is 1.05. And that's going to be raised to the 4 minus 1. So when I figure this all out, I'm going to take it in my calculator and do this. I get $23,152.50 for T4. Don't forget your dollar sign. We always go to dollars and cents when we're rounding, and that's my answer, T4. Now we can compare this to the other one and find out that, oh, this is indeed still lower than the other one. So, you know, by your 4th year, you're still making less money each year if you do the 5% raise. But watch what happens if we extend it. Let's do the same calculation, maybe even just going out, you know, 3 more years. Or let's go to 8 and see what happens. Okay, so I did this again with n equal 8, the same idea with T1 and D for the constant increase every year. So the 20,000 plus 8 minus 1 times 1,100, and got 27,700, okay? So that salary is certainly increasing, but look what happens at the geometric side of things, where 20,000 times that common ratio 1.05 is raised to an exponent 8 minus 1, and indeed it's more. And what you're seeing is the faster growth now that you've hit the steep part of an exponential. So this is going to start growing more exponentially, while this is just going to keep growing more linear, okay? So this is sort of a linear growth pattern, but this is more of an exponential growth pattern, okay? So, and as you know, this one gets pretty steep in a hurry. So definitely, if you're going to stay in the job for a long time, makes sense to take the percent increase. Okay, I'm going to make sure you can come up with this formula. Let's say you have a starting salary of $45,000, and you're expecting annual raises of 6%. How could you write an equation for your salary in any given year? Okay, so just to make sure we're clear on this, it's geometric because it is this percent increase. We'll use Tn is equal to T1 r to the n minus 1. So that means T1 is 45,000. R, because it's 6%, will be 1.06, okay? The 06 is the percentage, and the 1 is just, you know, you're increasing from the original. So 1.06 to the n minus 1, and that's your formula.